Hello, I'm Daniel Mello, and this is the presentation of Group 9, the second way, the principles of feedback. The Group 9 is composed by me, Daniel Mello, and Felix Issa Ashina. So, to start our presentation, we're first going to talk about complex systems and how a feedback will be so useful in such complex systems. So, to define a complex system, that is a system that needs to involve more than one person to comprehend and understand it as a whole. It defies completely the ability of just one person to understand all of its outcomes and how it is built or how all the parts come together. So a complex system necessarily needs to involve more than one person. That's why it's so important to have communication and feedbacks. In order to work safely in complex systems, there are four principles that need to be followed. The first one is to complex works managed so that problems in design and operations are revealed. So problems need to be seen in these kind of systems when they occur. Then these problems need to be swarmed and solved, resulting in the quick constructions of new knowledge. We have to not only solve these problems, but we also have to learn from them. Then new local logic is exploited globally throughout the organization. And the last point is that leaders create new leaders who continually grow these types of capabilities. Okay, so the first point is that these complex systems, they are designed in order to show the problems when they happen. And the first thing is to invalidate assumptions. When we invalidate assumptions, the faster we invalidate assumptions, the faster we fix the problems. So it's very, very important to invalidate the most assumptions possible. Then comes the principle of feedback and feed-forward loops. This is the point when people are going to communicate, they're going to evaluate the system and see where they can change and do all this. So it's very, very important to see the problem when they occur, and not only see it, but also we have to make people aware of it. So it's when it comes the swarm, solve, and build new knowledge. Once a problem is seen, once a problem occurs, is diagnosed through a feedback, then it has to be sworn solved in the fastest way possible. We have to go as fast as we can to solve the problem. I've seen something that one of the students said. He says that it is not possible to change a tire with the car moving. So what it means, I felt it was very intelligent, because like we have to stop the work to go and fix the problem. Otherwise, we're going to have a bigger problem after that. So first of all, the goal of swarming is to contain problems before they can change or they have the chance to spread, and to diagnose the treat before another problem can occur. The same problem can occur again. When you use this method, there are three consequences. First of all, it prevents the problem from progressing downstream. Then it prevents the work center from starting new wrong work. So it's really important, because this problem will start another. If it's not solved, then the new work is going to start probably with some or many errors already. So it's very, very important to solve this, because problems create new problems. And the third point is to prevent perpetuation. It means that this problem is not going to happen again. We cannot keep solving the same problem over and over again. We have to find a straight solution. It's much more interesting to work in the best solution possible than making workarounds and all these things. Then the third principle is to keep pushing quality closer to the source. It means one thing. Once the work needs to be done, there are people who will do the work itself, but we cannot. Sometimes they don't have the permission to do that. They rely on someone else's to make the choices. And I got here two different parts to show the wrong and right ways. The wrong ways and the right says require another team to complete work. After that, requiring approval from distant and busy people, creating too much documentation and large batches of working waiting for response. These things are the result of not doing things as they should, because in the right way it says everyone should fix problems on its own area of control. This allows people to have more responsibility, and I would say they have like the chance to solve their own problems. Then draw decisions to where the work is done, and share responsibilities. If someone is waiting to someone else's come and say what they should or not do, then it's going to take longer for them to do the work. So when we draw the decision closer to what the work is done, then it's done faster than waiting for someone to come and say that this person should or not do something. Once the person who is doing the work is able to make that decision, things go faster. So the point is that we need everyone in our value stream to find and fix problems in their area of control as part of our daily work. And finally, we have to enable optimizing for downstream centers. In the past, the external customer was the most valued customer, and it was the one who was paying for the product. But the point is that we also have internal clients, internal customers, who are the people who do the work. So it's very, very important to give them a functional, give them working and good operations so that they can perform the work. So the book says, in technology value stream, we optimize for downstream work centers by designing for operations where operational non-functional requirements such as architecture, performance, stability, testability, configurability, and security are prioritized as highly as user features. So the people who are going to do this part, the architecture, the performance, the stability, the testability, and so on, they will be able to do their job, and those are the ones who are working in the centers. So they will be able to perform their job in high quality, because the operations were optimized. So to conclude, as we could learn in this chapter, in order to have fast feedback, we have to see problems when they occur, then we have to swarm and solve the problems, and especially learn from the errors. After that, we have to keep pushing quality closer to the source by giving the workers the responsibility and make them make the decisions they have to. And finally, we optimize the downstream, we optimize the process to make the things flow. So that was it. Thank you so much for watching.